Hello, welcome back. So in this video, we are going to talk about functions and lambda expressions in Python. So functions are essential in Python for encapsulating and creating reusable blocks of code. They improve readability, facilitate easier debugging. They can accept parameters and return values. That's the beauty of functions. They accept parameters. So to make each function return unique and different values. And they allow for flexible and modular programming. So this is the beauty of Python. They allow your code to be more flexible and you can separate functions into different files and run everything as one. So lambda expressions or anonymous functions offer a concise way to create small single-use functions. So they are more concise and they allow for you to use a function just once without having to write it and use it multiple times, which actually take up space. So it's used for short operations and higher order functions like map, filters, and sorted. So in this lesson, we are going to cover both of these and learn how to actually use them. So to create a function, you have your define keyword here, followed by the name of the function, followed by the parentheses value here, okay? Once you have this, you successfully and you place your columns here. Then inside of your column, you create any statement or expression. You successfully created a function. After creating your function, now you need to know how to actually call your function. So we created this function. To call our function, you simply give the name, call the name, followed by a parenthesis. If I do not put this parenthesis, it will not bring in anything. We just bring out the location of the function without actually executing the function. This parenthesis allows us to execute our function. So this function prints out hello from a function, right? And that is the beauty of a function. Earlier, I said that your function allows you to take in arguments. What are arguments and what are parameters? So firstly, let's understand what arguments are. These are information that can be passed into your function. They are information that can be passed into your functions. These are called arguments. Arguments are specified after the function name inside the parentheses. You can add as many arguments as you want to, but all you have to do is just to separate them by a comma. So this is an example of an argument. We have the function, define my function, and pass in a parameter called first name. Okay, so this first name allows us to change the result of our function at any given point in time. So let me run this. So for each of these, I can get first name Emily. I'm going to get Emily Refness, Tobias Rennes, and Linus Rennes. So I can change the outcome of my function each time I run it because I have set a parameter and I passed in this argument into it, which makes my function reusable multiple times and produce different results based on the parameters I passed into it. Okay, so you heard me talk about parameters, you heard me talk about function, but they are slightly different between the both of them. But sometimes you can let me use them interchangeably, but there are slight differences between them. So for the purpose of knowing it, a parameter is a variable listed inside the parentheses when you are creating your function, while an argument is the value that is sent to the function when you are calling it. Okay, so in this scenario, this part will be called your parameter, while this part will be called your argument. Okay, so let's run this and get our answer. Got Emily Remes, right? So you can specify, okay, we want to change this. Let's copy and go back to the bottom and say archive Excel. So the first name will be Excel and the last name will be Aka. Okay, so it's working perfect. I can create as many name combinations as I want to, as long as I have the first name and the last name. So the beauty of this, we'll see this later on. Maybe I can give this you can use a list, you can pass in your list and run this as a part of a for loop to print as many names as you want to. So if you try to call the function with two or more arguments, there's an example here where when you create a certain number of arguments, you say this function has two arguments, and when you try to call it with just a single argument or more than the numbers of parameters you set, you are going to get an error. So look at this example. Let's run this. We are going to get an error let's put in multiple than this. Let's say Finn, and add another one, say Jean, right? And let's put a number here. Run this, we are still going to get same error. The first one said function takes into parameter but got 3. When we did the opposite, we say function takes in 2 parameter but got 2. Okay, you can see that you must put in this exact amount of parameter you set as arguments. You must put the exact amount of parameters for your arguments. So there is a workaround around this, which we'll do later on. Okay, so this is a quick example or a test to create a function that calculates the mass of any given object, right? The force of any given object. So we know the mass and we know the acceleration. We say F is equals to mass times acceleration, then print out F comma N, which is Newton, for the value. So when we pass in any value, we can instantly get the resulting value for that. Let's run this, let's run this, let's run this. You can see, change my value, I'm always going to get the correct force all the time. This is another example to calculate, to convert from Fahrenheit to Celsius. So at any point in time, I can always get the correct value. So let's use 273, run this up, and we'll get the correct value. Let's use 150. Always get the correct value here. 200, okay. 213, 212. Okay. So 212 is 100 Celsius. So you check it out with your converter and you get the accurate value. So this is one of the beauty of function. You can create something and use it as many times as you want to, and you still get the correct value, depending how you structure it. So functions are one of the most important and most beautiful part of programming in general. That leads us to arbitrary arguments. So there are situations, remember when we talked about argument, that you have to, the parameters you set have to be the same with the arguments you pass in. But there are situations where you know that you're going to pass in multiple arguments, but you don't know the exact numbers of argument. That's where your arbitrary argument comes in. So to create this, you have to, when you're passing your parameter, you put in the name. Let's use the default method, argument. You put in an asterisk before a particular word. Then when you are calling your function, you can pass in as many arguments as you want to. What simply happens is this: each of the arguments are placed inside of a list, and you can now access any of the arguments with that keyword here, right? That's why you can see I'm using a square bracket, meaning this argument is basically a list. So let me do a print type, print, okay, let's do something else, let's see. Print, then the type of args, you see that it's a list. Okay, sorry, it's a tuple. It's a tuple because it will not change. Once you set it, it will not change again. So it's a tuple, meaning it's still kind of like a list, but it's a tuple. It's unchanging. So there's another form of argument, which is your key value argument. In this scenario, there's another form of argument, which is your keyword argument. So in this scenario, the only difference within this and the other one is when you are passing in your arguments, you use the key rather than just passing them randomly. So in an example, if I had done this, let's grab this, and I pass this like this, child 1 is equal, okay, let's just do this instead. Pass this like this. Automatically, Tobias will be the third child, Dave will be the second child, and Linus will be the first child for the first example. So if I say print, okay, print the youngest child, print the third child, it's going to now be Tobias. But this is if I want to specify, okay, I want the third child to be Linus. I have to pass in my key as a form of variable, then pass in it has to bear the same name as it does here, right? Then pass in my value as my argument as the value. Okay, so you can see Linus has passed as the value here. So when I run this scenario, you're going to see the youngest child now is Linus. Okay, so with this, you must always also pass in the correct numbers of, let me do this. You must always pass in the correct numbers of arguments as well with this scenario. But in a situation where you don't know the numbers of arguments you are going to pass in, you can also use an arbitrary keyword argument, which is the double asterisk. So if you don't know how many keyword arguments that you will pass into your function, add the double asterisk before the parameter name in the function definition. So basically like this, you can say, you can use any word you want and it will still work. But ideally, you want to use the conventional method, which is just using this args like this, and do it like this, which simply is short form for keyword arguments. Okay, if you got our correct answer. So now I can add as many keywords as I want to, and I'll still get the correct one. And when I'm calling it, it's kind of like a dictionary. Let me show you this. It's presented almost like a dictionary. It is actually a dictionary. The keywords are gotten as are saved as dictionary. Let's print this. Type equals to, okay, I think I'm doing something wrong. Go back. Okay. Open this up and pass in my keyword arguments. Okay. You can see it's a dictionary. That's why when I'm getting my values, I need to know the key in order to get the value. So in function, you can set a default value for each of your parameters. So in case you did not pass in any value, the default value will be used. In this example, we have country equals to Norway. So in a situation where I'm calling my function and I do not pass any parameters into this country, I'm going to get Norway. Okay, so in this first one, I'm going to get Sweden, India. Then this one, when I'm not passing it, I'm going to get Norway. This is the beauty of the default function. This prevents your code from breaking. Right? Without this, if I run it without passing an argument, I will get an error immediately. Okay. So let's Ctrl Z that. Let's go back. Ctrl Z that. Okay. I run this again. You see where I'm getting my correct answer. You can also pass a list as an argument. You can pass anything as an argument, basically. You can pass a list, a tuple, and any other value as an argument, and you can also work with them within your function. Okay. So earlier when we're calling our function, we always print our function, right? But this is not the ideal way you need to call your function. You need to create your function. Your function needs to return a value in order for you to reassign that value to another variable. Let's give this as an example. This is my function. So see, let's do this as an example. If I were to print this value here, let's go open up. Open this up. Close this. Let's just rename this for the sake of not retyping this. If I were to say, okay, assign this value, let's call this val is equals to my function. Let's do this. If I try to assign this one that I printed to another value, let's do this instead, to another value, and try to print this one, or so even better, let's say value multiply. Let's multiply it again by 2. When I try to run this, what am I going to get? Okay, sorry, let's do this instead. This one, try to multiply it by 2. You get an error, meaning unsupported operation for a non-type, right? Meaning this print comes out as a null type and it just prints it out. When I run this one for this scenario, it prints the value of 5 times x, but this value now, I cannot reassign it to any other variable, right? So that's why you're getting this error. But if I return it, this value now becomes a free value, a already calculated value, and it's ready to be assigned to any other variable. Let me remove this and run it, and I'll get my, let's see, okay, I deleted this. I get my correct answer. I can multiply this even if I want to. Multiply this here. This by 3, and I still get my correct answer. You can see this example. When I returned my false, I was able to reassign that value to, I was able to calculate on that value and get another, and use it for another calculation. But if I were to use print, I will not be able to do this. Or if I were to leave this out, I will not also be able to do anything with this value. Okay, as you can see, so you can say that this function returns nothing, so I cannot do anything with it. Unless you put your return, your function will not be reusable by another variable, another calculation. So like in any of our blocked data structures, we can also pass in our pass to act as a placeholder before we actually know what we are coding, as a placeholder to hold our thoughts and just keep it there. We know we are going to create that function, but we don't know what it's going to do yet. You can use the pass as a placeholder, then move on. If we don't put this, we are going to get an error saying incomplete. Okay, expecting a value, expecting an input. So on this, expect incomplete input, okay? Okay, so if you want your variable to be position only, meaning I cannot use this keyword, I cannot be passing keyword here, I will put this slash after my variable. So now if I want to use this, I have to go like this and go like this. But at the end of the day, this might not be very useful for your use case, because most times you just want to just do it as simple as possible. So you want to use the normal method. So by default, if I do it like this, I can pass it as a keyword argument or as a position-based argument. So like this works, and okay, like this also works. But if I want it to only be keyword based, so I need to know the keyword before I can pass it in. Okay, this is also not going to work. If I need to know the keyword before passing it in, I'll use the asterisk after. Asterisk comma, then the keyword. So when I want to pass this in, I must, so you can see it's working. But when I want to pass it in, and I use the position only, I'm going to get an error, because will tell you the function takes 0 position, but 1 was given, right? It gives you an error. But you can also combine both position only and keyword only. I say from this variable, this parameter to this parameter, make sure it comes as position only. Then from here beyond, make sure it comes as keyword only. So if I do something like this, I said b is equals to 6, and I run this, I'm going to get an error unless I follow the rules I set for myself. So let's go to lambda function. Lambda function allows us to write a function in a more concise, and make it, and the function, most times before you use the lambda function, make sure the function is something that you use only just once, because once you create that function, you cannot use it in any other place. You have to use it where you create it. So your lambda function goes like this. You have your lambda keyword, followed by your arguments, then the column, followed by the expression you want to calculate, right? The expression you want to calculate. So once the expression is executed, it takes in your argument, executed expression, and returns the value. Returns the value of this your expression, the resulting value of this expression. So if I say, if I pass in a, and I run it, it gives me x equals to 5. Okay, if I pass in 55 and I say 55 plus 10 should give us 65. So I can reuse this only if I pass it as an argument here. So I've used this basically in data analysis. You tend to use this with your apply method, your filter method, and your map method. Those are higher order functions. So your lambda function can also take in multiple arguments like this, and it will still work. You can take in up to as many arguments as you think you need to take it in, and it will still work. So you might be wondering, why do you need to use a lambda function when you can also do that thing with just a normal function? So the power of the lambda function is better shown when you use them as an anonymous function inside another function. So if you want to put a particular function inside of another function, you can just use your lambda function to do that. So we have a function takes in n, but in that function, we want to also do another calculation. So you can use your lambda function. This is just a simple explanation of this, but you can also go even deeper. So these are some examples of your lambda function. Let me just run them. So when I call this, let me just call this my function takes in, let's say 2. Run this up. Takes in 2 and I think this should return something. Let's pass in. I think we need to pass in a as well. 2, 3. So with the lambda function, we can create a function inside of another function, which we can then use for any other thing we want to do. So given this example, we have my lambda function, which takes in this, right? So this function, when I run this, I can assign it to this. Then this new variable can also be a function because it equates to this lambda function. So I can use this as many times as I want to. Basically use this. Right? So that's basically it for functions and lambda function. By understanding functions and lambda function, right, it's a very vital part of being a data analyst because you are going to use functions a lot. Functions allows you to create reusable and modular code, make your analysis process more organized and effective and efficient. So your lambda function provides also a quicker way to do some quick operations, some quick and simple operations, which is particularly useful for data transformation and data manipulation, which we'll get to use very soon. So do leverage what you've learned so far about functions and lambdas to create more complex data analysis and get more tasks done using Python. So in the next video, we'll continue and learn how to actually do your analysis with Python. Now that we have gotten the fundamentals of Python programming, we can move forward and learn how to do our analysis using Python. So see you in the next video. Bye for now.